Well, welcome everybody to our webinar. My name is Juan Das. I'm the Business Development Engineer here at Meteodyn, and we're still waiting for a few other participants. So right now we're going to conduct just a little test to see if you can hear us and see my screen. So just answer the questions that will appear on your screen. Okay, welcome everybody to our webinar. I'm Juan Das, the Business Development Engineer here at Meteodyn. And joining me is Baptiste Carrel, the Product Manager of our software. We're glad to present to you our new CFD wind resource assessment software, Meteodyn WT6. I wanted to let everybody know that this version has been completely rebuilt from scratch. We created a software platform called the Meteodyn Universe, which includes Meteodyn WT6. We did this because we wanted to create a modular software platform which would allow us to add as many modules as we like. This means that as new functionalities become a requirement or a desire in the wind power industry, we now have the possibility to add on modules in a simpler, quicker, and more reliable manner than other non-modular software. Also note that we have 35 software engineers and 10 research scientists who work full-time to improve our software, making it more accurate, faster, and simpler to use. During the webinar, you may place your questions directly on the chat box, and at the end, we will respond to as many of them as we can. All of the questions will be answered to all participants via email. Now I'll leave you with our product manager, Baptiste Carrel.
Hello everyone. As Juan told you, we'll give you a quick overview of all features of WT6. As he said, we start from scratch with this software, and so we were able to make it all modular. And but we also change the way we are sharing data and running computation. So I'll start with this point by presenting you all the different configuration of WT6 that you can use within your company. So the first configuration is the historic one. It's the standalone mode where the software is installed on your computer. You can launch CFD computation and all other computation directly on your computation, and results are stored directly on that computer. But with the new version, we introduce new way of sharing this data and running computation, which is the collaborative mode. So many users can connect to one database, which is installed on a server, and each user can launch computation on its computer when it gets results. All results and all data are stored in the database, so you can log to the database everywhere on the world and find your project and results, and you can share them with other users connected to the same database. We also developed the more elaborated configuration, which is the client-server mode. So that's basically the same than the collaborative version, but once you create your project on your computer, you can launch directly computation on the server, and once you get results, they will be also stored on the server, and other user will be able to consult the result. So basically, you don't need, with this configuration, you don't need any computational power on your computer. All is on the server, and So the server can be also on the cloud, so you don't have to store any data on your own computer. So once you'll log in the application, you'll have to create an account, of course, and to parameterize the information to connect to one database or to run in local. And you can easily switch between each configuration. So now we'll switch to the software. So I can give you a live demonstration or on how we can create a project from scratch and run the computation. So when we log in the software, we arrive on the dashboard page, which is an overview of all sites created by users of the database. So that might be all the users of your company. You have information about all the sites on this dashboard also. But first, as I said, WT is not a modular platform, so we add some external tool. We are not in the site right now, and so I'll start presenting the external tool first. So we have the dashboard that I show you. We also have the site management tool, which is basically a tools gathering all different projects where you can edit them, you can share them with other users connected to the database, you can edit them, and you can import new projects from past version. We have then the geographical data management tool. So that's basically a catalog of all geographical data that will be imported in the platform by all the users. So here is basically a catalog of all orography and relief data. And once we'll create a site, we will choose one of these terrain data to run our computation. We have the same kind of tool with meteorological data. So that's a catalog of meteorological mast or any measurement devices. When you create, one object represents this meteorological mast. So once you get in it, you have information about this mast, location, time of measurement. You can import data, time series data with all formats. We don't have any more formats, fixed formats, so you can import every kind of data, time series data and frequency matrix data. Once it's import, it's stored in this object. So for every height, you have every variable you imported, and you are able to generate frequency matrix from this time series. So now you can directly display the matrix. You don't have to wait for the synthesis to display them and check if we are using the right data. You can do the same for turbulence intensity, and you can display all your wind distribution for every height you get measurement. So once again, here is a catalog of meteorological data, and once we will create a site, we'll choose one of these data to assign to a mast. And we get the same for wind turbine types. So you can create your own catalog of wind turbine types. So it can be one user of a company that creates those types, and then other user will just choose one type to use during the synthesis. So you can edit one type. You have information about wind turbine type. I don't have stress curve in this one, but if I edit another one, you can import stress curve in this type, power curve and stress curve, and display them. So that's it for the three data management tools. We'll see how to use them later. We also have the LiDAR converter tool, which is basically a tool to generate LiDAR correction file for LiDAR in complex terrain. We also have all the user settings for different parts of the site creation, your license options, so depending on which license you have, and the user manual. So that's it for external tools. Now we'll see while we'll enter into one site. So to do that, you can go to dashboard, you can select one site and just edit it. You can have several sites open at once. But when you get in a site, its site is split into two parts. The left panel is for all parameters of the site. So you will configure your site in this part. And in the right side, you have a map when all elements and all terrain data will be displayed when you configure it. So you can display the terrain data in 2D or in 3D, for example. We improve this 3D visualization to be more performant and the way we are processing terrain data. So we are displaying exactly the information that will be used during CFD computation. So you can check if the file is well processed or not. So for in one side, we still have all the steps of creation. So site creation when you are dealing with terrain data. The elements when you can add wind turbine or mappings, the CFD to run CFD computation, the synthesis to process the CFD results to get production on your park or any other results. And for this version, we add this new step, which is optimization, and we'll get to that later. If I just open a new site, so I have nothing on my map, obviously. So first thing to do is to define a projection to work with. So here it is. Then you can just add terrain data. So to do that, you're just gonna pick one file you importing in your catalog. So you don't have to import anything once you are creating the site. So here I just select my files. I can display the boundary of my file so I can check if it's the right projection and if I have enough data. I can also select roughness information. So I can use my file or I can also use databases that are directly in Meteodyn. So like current land cover, for example, if I select this database, so I need internet, but I can display all the information of current land cover database, and I can directly use them on my site. Once I have my terrain data, I can define my site, the center of my site, and the radius. So here is my radius when I will be able to have result to set elements, and here is the data radius. So basically the data I need to run the CFD computation. So I can easily check if I have enough data to run the computation. Once it's okay, I have all my terrain defined, so I can go to the element tab where I will be able to place some elements. So we had a lot of map interaction in this new version, so you can just create element on a map directly. So I can easily create a mapping to do visualization or wind resource map. I can add some meteorological mast on my site. wind turbine. Obviously, I can do it on my map directly, but I can also import layout files or define them by just tapping the coordinates, and the map will be automatically updated. Once I have all my elements, I can go to the CFD computation. So we'll find all the classic parameters of our CFD solver. So the mesh parameter, the thermal stability class that you will be able to run. You'll be able to run different CFD, different direction, uh, and you will then use it during synthesis. We had some options, so we still have the auto convergence tools to get to be able to automatically rerun CFD computation in order to be sure your CFD computation will be converged. For this new version, we considerably improve the computational speed, and we also add parallelization, so you can select as many core to one computation, and the more core you select, the quicker you will be your CFD. So basically, the only limit is your computer and it's not the software. And all advanced CFD parameter, of course. So once you define all these parameters, you just have to run your CFD computation. So either on your computer, or you can send them in a server if you have the configuration. So I won't be launching computation here because we don't have time, but I've just moved to another project that already have CFD computation. So once you launching, you get to the result and you can follow the computation. When it's finished, you can display all results. So you go to one CFD computation. You can display directly on the map the result for each variable, each height. You can display the mesh on the map, 2D mesh. You can directly have results on your in the interface. So you can select each point, you can select each variable, and just have the result directly in the interface. You don't need to export any files. You can follow the convergence. So here is the same kind of window. You select your element, you select the variable, and you can see for each iteration of the CAD solver the evolution of results. So you are able to determine if your CFD computation is well converged. We also add for this version the Flores result export, so that's a file format for CFD results, which can be read in WinPro, so we can directly use our CFD results in this software. We also have all other exports to be compatible with display software like TechPlot or PowerView. So once you get all your CFD results for all stability and direction, you can go to the synthesis when you will process these CFD results, and you will have wind distribution, wind production on your map. So we made a lot of work for this part to be really easy to configure. So what you have to do first is to select one layout. So you don't have to take into account all elements, and you can launch several syntheses with several layouts to assess the best solution. So I can change my layout and it will automatically be displayed on my site. Then I have to assign measurement data to the mast I created. So I can easily add several meteorological data. When I just have to go to my catalog of data and to select which measurement correspond to the mast I have. I can select different height of measurement. And once I assign one measure to my mast, I have a summary of all the data available. I can use time series data to get time series result at each point on my site. I can easily configure weighting for if I use several masts. I can tell that one mast will have more influence in some area. Then I select the CFD results. So depending on which stability I measure on my mast, I can select several stability on this part. So in this part, we have some rules to respect. So we have a lot of running message to inform you what may be wrong with your configuration and to be sure you do it well. Then you have to assign one type for your wind turbine. So here again, I don't have any import to do. I just go to my catalog and select one type of turbine. I do the same for the mapping to get a production map. Here it is. I can select to assess wake effect, choose different models that are available in WT, and compute extreme wind speed. At the end of the synthesis configuration, you have a summary to to know before launching the synthesis what result you can expect, and you don't have to wait the end of the synthesis to realize that you forgot something in your configuration. So once all the configuration is okay, you can run it and you get to the results. So you can launch several syntheses with different layouts. So the layout automatically appear. And just like CFD results, you can look at results on a map. So you have much more result here because you have wind distribution, turbulence intensity, production, etc. For each, you can also display results for each point of your site. So here, once again, you have a lot of results, and you are able to just display them on the interface. We have our losses and uncertainties tools, so you can just fill this information. We have an automatic reports, so which gather all CFD results used in your synthesis, all mask configuration, wind turbine configuration. So it basically gather all the information you need to do a report. We have some Excel files for results, IEC check loads, and all formats of wind speed distribution map. So you can directly export them and use them in software of wind resource assessment. So once you finish the synthesis, is basically the end of WT. But as I said, you have to test. You may have to test a lot of different configurations to find which one is the best. So that's why we add a new step, which is the optimization, that permits to automatically determine which will be the best configuration, and just have to launch one synthesis. So you have to tell which are the constraints you want to be for WT to be able to determine which will be the best considering those constraints. So the first constraint you can take into account in this optimization is constraint area. So you'll be able to import shape files in the interface, and they will appear on the map. So like city, forest, and in this area, the optimization won't be able to place any wind turbine. You then have to choose one synthesis because you need a wind resource map to run the optimization. because we need to assess the production of each wind turbine at each configuration. And then you have a tool to tell the optimization what elements you want to place on your site and which wind turbine type. So I won't get into detail for these parts, but we can really set a lot of different scenario. So first one, you have to tell which spacing you want between your turbine. So we WT consider an elliptic shape around each wind turbine that can't cross each other. And then you have to tell the software how many wind turbine you want. You can tell you want like 30 wind turbine in a total. And then you can create different group. You can tell you want some wind turbine of one type, like 10 wind turbine of one type. So here again, I go to my catalog and select one wind turbine type. I can create another group, which is like 20 turbine of another type. And the process will automatically choose which one is the best type and the best location. So you can add a group of 10 wind turbine with different wind turbine type, and we'll choose the best one depending on the location, etc. You can also define fixed location wind turbine if you want to take into account already existing wind turbines that you won't be able to place any wind turbine near this one. And once you configure it, you have to go to the parameters, so which value you want to optimize. So for now, in the optimization, it's energy production or capacity factor. And you have to define a stopping criteria, which is a duration or a number of iteration. And then you can run your computation. So once again, it's either on your computer or on a server. Once it's finished, is once again, just like CFD synthesis, you have all the optimization. So here I have just one. You can display convergence of the optimized functions. So here is annual energy production. So you can see it's converge really quickly on this site. And you can have all the results. So the result is, so each wind turbine you define, optimum location, optimum height, the estimation of annual energy production, capacity factor, and the best wind turbine type for this location. So here it's only an cone. Once you get this layout, you can just export it in your computer, and you can go back to the element tab, and you can just import the optimized configuration. So here my turbine appear. So I still have the old one, but the new one are optim. And if I check, all the optimized wind turbine are outside my constraint area and all where you have the more production, and they are still we respect the spacing criteria. So once you have that, you don't have to rerun CFD computation. You can just use the post CFD processing to get CFD result on this point with you already launch CFD. So you can directly launch a new synthesis to get all the results, i.e. a better prediction estimation on all these points. So you don't have to launch a lot of synthesis to find the better configuration. So that's it for me. It was a quick presentation, so do not hesitate to ask some questions on this webinar, and we'll just answer this question now.
Thank you very much, Baptiste, for that very complete explanation, and thank you everybody for listening. Now we're gonna move over to answering the questions that were posed by the attendees. So we have one question here. Let me just check. So the first question is it possible to import data from different types of logger in the raw form, e.g. NDF, log, dot, or RWD, among others? Well, remember that we now have the import wizard, which allows you to import any type of data, and you can select where you have placed the columns and what each column means for your data. So you can customize it any way you want. So we can import any data. So it's you just need to tell the software which column corresponds to which variable and in which unit, and he can import everything. Which is one of the things we did for WT6, one of our major improvements. Okay, the next question is during the optimization, can we give some buffer distance from the constraints, e.g. forest, obstacles, etc.? Can we, Baptiste?
We can't do it for now, but that's something we work on. We already developed for internal tools, but not already. It's not already out for WT. But yeah, we plan to be able to define a buffer and also to define around constraint area another area which has some where you can place wind turbine, but you have to pay more for this area. So that's something that will be, we don't have a date, but that's something that will be out in the future.
Well, something that occurs to me here is that you could, since you want a buffer zone, including the constraint areas, you could select the zone to include the buffer zone already. So if you were to do that,
Yeah,
you could
of course.
counter this problem. So that's all the questions we have for this evening webinar. Thank you everybody for attending and have a nice evening. Bye.